Testing, yeah. That's good. All right, it's been a little while since I've spoken with you. I think it was week 6. I skipped a lot of the Ruby stuff. So today, though, I'm back, and I really enjoy this one. I try and teach this lecture every cohort I can, because it's sort of it's about RSpec and Rails, but it's not about RSpec and Rails. It's about testing. That's what I want to talk about today. Testing, because testing is super important. QA in our programming is just as important as writing the programs themselves. No one writes perfect code, I promise you. No one out there, no matter how much experience they have, they don't write perfect code. So everyone has to test. You don't get away from that. And I'm going to talk about test strategy today, how you actually could create a test strategy to apply different types of testing to different areas of your software, because that's actually a pretty good way to balance things out. Okay, so although it says feature testing with RSpec and Rails, that's a small part of today. That's a small component. We will be doing that as an example. We'll be building some integration testing into the Jungle application. We'll have robots do the testing for us. It's actually pretty exciting, I think. And before we get to that, though, we got to talk about some cool concepts that are out there, and hopefully the teams and the companies that you get hired onto employ some of these practices, because it really does lead to better software. So, like I said, strategic testing is important. CI/CD, those stand for continuous integration and continuous delivery or continuous deployment. I guess it really depends who you talk to, if it's delivery or deployment. But the idea there is that there's an automated process where when you commit code, it makes its way through a process of building and testing, and then potentially automatic deployment to your actual production server so that your clients get that change pretty much immediately. There are different levels of this, so we'll talk about what that could look like. And then the details today are all around RSpec and Capybara. Those are the Ruby libraries that we will use to implement some integration testing. Okay. So like I said, excuse me, strategic testing. There's not just one way to approach testing, but how have we been testing our applications so far? Yeah, manually. So that's a very legitimate and commonly used form of testing. Sometimes companies will hire entire teams, and their sole responsibility is for tracking and testing manually the software. So that's pretty expensive, though, right? Because a lot of times we also, so if you're going to build your own team, that's expensive. And if you're going to ask your high-paid developers to do the testing, that's also expensive. So we need to come up with ways to minimize the cost around testing, and one of the ways is to automate manual testing process. For now, manual is fine. For your final project, manual is fine. For a lot of sort of one-off tests, manual is fine. But if we're going to be testing the same thing over and over and over again, we should move away from manual testing and try and make things a bit more automated. This is always the situation we're up against, right? We get to choose just a few. We don't get everything. And so there has to be a balance how we approach this. And that's why I say test strategy. The test strategy is how we take this and balance out the different types of testing and apply it to the different parts of our software. Some parts of our software are more important than other parts of our software. Right? So we want to be ensuring that we're testing that important part of our software really thoroughly, and maybe take a little bit of we'll spend a little bit less time and money on the things that are not changing often or not as important to us, maybe. Okay. I definitely see some companies will put maybe an emphasis on testing the software that goes out to their customers, and maybe spend a little bit less testing the software that's internal, where they can absorb some of the pain that goes with that, right? So the strategy is going to be different based on every project. That's why humans still do this work, because we have to actually apply the strategy ourselves. So manual testing, the great thing about manual testing, real user interaction. I think that's a really important part, right? We mimic our users. We try and pretend we're our users, but we don't really, do we? Like, we don't really do a good job of that, I think. Because we'll test the good things, the things we know to work. We'll test the email that we have in there that works just fine, and maybe once we'll test what happens when we put the wrong value in there or something weird. But this is what we need to be thinking like, right? If you talk to any people that are very experienced with testing, they'll try to put every single option that anyone could ever put into this input field, the single input field. What could anyone put in for a name? What could they put in for an email? Could they put numbers instead of letters? Could they put large 1,000-character blocks of text? They'll try all these things because they know one thing. They'll eventually break it, right? This is the mindset we have to put ourselves in. How do we actually make sure that we're not just testing the good stuff, the stuff we want to confirm works, but also how do we test the things that people could potentially put in there? So this is what I mean by real user interaction. I don't just mean they go through the process of using the application. They also go through the process of using the application potentially wrong, right? Ways that we did not intend them to do that. So that's an important point. We'll also hear about code coverage. People will talk about code coverage. Code coverage is this metric we can use to figure out maybe how many lines of code or how many of the functions in our project are actually tested. And we can do this automatically. We can have it go through and potentially even listen in and read and hook into the code and figure some of this stuff out. One of the tools that are in use for this, which we won't use, is rcov. Actually, not that nice of a name, but it's a tool in the Ruby environment for coverage. There's lots of different tools like this, though, right? Let's take a quick look at React on GitHub and see. I'm going to show you something that you may have noticed before, and if anyone clicked on it, then these little badges that GitHub is providing for the library owners, right? So coverage says 90% here. They also say Circle CI passing. This is Circle Continuous Integration. It's a service that someone has created where you pay them and they run your app over and over and over on every single commit to make sure that it still works. So these tools are pretty useful. And we can click into these and see what some of them might look like. So I go into coverage here, and it's going to coveralls.io. So this is a SaaS product someone created to measure and record over time the testing coverage of the code. See that React, right? We got maybe a little gap here. What does this gap mean? This little it means that somebody committed code without the test for that code. So our test coverage goes down. And then maybe a little bit of time later, they add a few of the tests in there and it goes back up again. That might be what that means. But they are keeping track of this, and they have a target metric for this. And likely they will say, if we go below 90% or 85% or whatever their metric is, then they now have to spend some time in their next sprint actually increasing that value. Because performance, these targets can go right into your performance metrics, so how fast your app is running, whether or not it's meeting those targets, whether or not the test coverage is at a certain level, whether or not it has. There's all sorts of metrics we use when we're running a business, and code coverage could be one of them, right? Okay, so the other thing, I will come back to this other one, which is Circle CI. I'll come back to that after. So, like, what's a good code coverage percentage? Fuck. 100. Okay. I mean, yeah, that I guess in an ideal world, right? We would say 100%. But I want to make sure that we don't think that is the only good number, because, like I said, the target is project-based, and it depends on your strategy. If you only have 20% coverage, but that coverage is making sure that the most important part of your application is working, then that could be good for now, and then maybe we spend some more time later. We don't need to shoot for 100% in the first week. That's unlikely that anyone hits that, and you know, it's easy to spend that time on other things. So let's just keep in mind what the project is. Not always go for 100, but that 80 and 90, that sounds pretty nice to me. Okay. Yes. Yeah, that's a good way to. Yeah, it's a good way to put it. I've seen in one of the applications that I was working in, one of the games, there was a guy, and he came to me with this idea that they could actually hook into every single function in the game and record when it's called. And then what they do is when they send a game build down to the manual QA testers, it would run this as well in the background, and it would report the information back to a server. And then we could actually see after that round of testing, through manual testing, how many of the functions actually even got run. Was it only 60% of the code in our application that was used through the normal use cases? And we could get that number back and start to understand more about our code that way. So lots of different, this could mean a lot of different things, but it usually references a percentage of your code that's tested. Through automated testing usually, though. Yeah. All right. So unit testing, lots of cool benefits to unit testing. Encapsulation. So what does encapsulation mean? Yeah. So maybe everything contained within. Everything we need contained within could be a way we could talk about encapsulation. So unit testing, we're testing this one function, and usually we're testing to see if I give it certain inputs, it'll give me these outputs, and I can just give it different inputs and expect different outputs. And that would be sort of unit testing, and encapsulation means that everything happens within that one function. Okay. Okay, so speed, I'd say unit testing is faster. Once we write the tests, then to run those tests, it's going to be faster than we could manually test all those different functions by writing the code that would call that function, passing that. I mean, eventually that's what we've done, right? So unit testing we don't manually unit test. We just don't really do that. So unit testing would be mostly an automated system, and speed is a benefit there. The word regression when it comes to testing, what does regression mean when it comes to testing? Testing past code, yeah? Is that? Yeah. Okay, cool. So if we find a bug and we fix that bug, we don't get to now forever ignore that bug. We actually, unfortunately, we have to put that into some sort of record keeping and say, every time we release our application, we have to test to see if that bug still exists or not. So the normal flow through maybe a development of our project is you start with very few bugs in the system, not in the code, but in let's say the recording software. Maybe it's just GitHub issues, for example. So there are very few bugs there, so you got QA going through and finding these bugs, and then as they find more bugs, they're adding more issues, and your issues numbers go up. And now they're over time, they're finding fewer and fewer bugs every day, but their workload doesn't go down because they still have to go back and test every other bug that they had found before against the new versions of the code. That is regression, and automated regression can save us a lot, right? We don't have to necessarily, we can record that that bug existed, sure, in something, a bug tracker or an issues list. We can also record it in our unit tests by running a test that tests that to see if that bug still exists or not. Or even in our functional tests if we want to. I would say that a lot of these benefits are not specific to unit testing, but with regression, we probably want to write a test that will continue to regress that bug so that every single time we change the software, we run all of the tests, which means we do all of the regression we need to. It's very costly to do this with manual testing. Okay. Confidence. So I've got confidence down here. Testing, higher levels of testing give us higher levels of confidence, gives us confidence to release the software, maybe on a more iterative or continuous basis. We definitely, business can really benefit from being able to change the software quickly with low risk. So automated testing gives us confidence. But I've also put reliability and stability here. And I would argue that reliability and stability is what gives us the confidence, right? But I put it separate because I do want to call out another very important part of why we do good testing before we commit our code. So who cares about reliability and stability of the software? Of course, apart from the client. Who? Well, yeah, so the user or the client. But what about you? Do you care while you're writing the software that it's reliable and stable, right? So this to me is all about the developer at the end here. Because if a team wants to move quickly, then we can't break master. If the team wants to continue to improve the software, to not always be fixing bugs, then we need to have reliability and stability in that software so we can continue to move forward and deploy this thing. So I would say confidence allows us to release to our users, and reliability and stability is what's letting us move quickly and fix and add new features, okay? Always going to have sort of the other side, right? Testing's expensive. All testing's expensive, though. Unit testing's expensive up front. We're going to learn about it so that we can potentially make it less expensive. You try and leverage old work for new work. I'll try and show you some of that today. And it's expensive because we have to maintain unit tests. We have to maintain automated tests. If our code does one thing one day and we write a test for it and then we decide that the code has to do something else another day, we also have to change the test for it. That's maintenance. Should be out in the open though, right? That's fine. We don't hide that type of stuff. It's difficult. I think it's difficult, at least at first. You have to put yourself into a different mindset. You have to think about, actually, it's a really good exercise to think about how you would test the software you haven't written yet. That's test-driven development. And it really makes you think about all the features and how the software would work, and you can iterate it on it at this level. Like I can figure out what my test would even be, and we can improve and sort of focus the product more as a result of that. What does the login field say when someone puts in the wrong email? Let's find that out now while we're thinking about how we're going to test this software. And you could actually even say that you could write acceptance tests that would be used to accept that the software meets the features that are out there. And the definition would be what happens when someone puts in the wrong email address, what the text says, and you can use that as a reference when you're actually writing the software as well. And if you decide that up front, then when you write your test, you say, I put in this input field, and then I look on the page to find if it says, please put in the correct email address, or user, you have put in the wrong address, or whatever the message you want it to be. You can kind of decide that up front. Unit testing is also specific, and so that's really the only problem we're trying to solve today, is that we're not looking at a specific encapsulated chunk of our code, but actually how different features work together. So the one we want to talk about today is with Jungle. I want to make sure that ordering is rock solid, that our orders are that the process of ordering is tested with every single commit that we make, so that we are the ones that find out that it's broken, not our users. That's, I think, critical to our business. So it will not be a specific test because we're going to have the automated system log in as the user, add a product to their cart, go to the cart, hit the pay button. It'll bring up the Stripe form. It'll automatically put in the credit card number. It'll hit submit. And then we're going to confirm that on the last page it says thank you for your order, and then their email address, whatever they put in for that, right? So that's what we'll do in our exercise today. And we're going to use feature integration testing. I think you can use these terms interchangeably. That's my opinion. That feature and integration testing. Feature testing is, the feature is, do orders work? The integration is, does orders work when I'm logged in, when I'm logged out, those types of things. But the key is we're simulating user interaction again. And in that case, we might want to also try things that users might not be their natural flow, but some couple, like one-off users could do it, right? Okay, questions about this test strategy? Yeah. Yep. Right. Well, so yeah. So the question, just for the video, the question is, if we write tests for all of our login functionality, right? Yeah. Automated tests for our login functionality. Feature, yeah. So yeah. So do I need to retest all my login stuff if I'm changing code that's unrelated to login? Is that right? Yeah. Yeah. Okay. So manually, that seems to matter because manually, it takes my time no matter what. And so if I change a feature that doesn't really have anything to do with login, or even if it does have to do with login, I should be testing the login flow at that point. But if it doesn't have to do with login, then I might be able to skip it through manual testing. But when we write automated tests, we could just run those after every build. And it's very cheap for us because even though the test suite might take 5 minutes to run, it takes 2 seconds to start. And then you get to check your email, grab a tea, use the washroom, whatever it is. And that is not active time. It's a different type of time. So I would say, yeah, running those tests would be worth it on every single change, even if your change did not modify the login flow. If those tests took 2 hours to run, then you got to think about it different and run just a specific portion of your tests as you're going through. But maybe it's running the entire test on every single thing before you're pushing that out to public, to production. Does that kind of answer your question, or can we keep working on it? Okay. Cool. Anything else? All right. So I also said we'd talk about continuous integration and continuous deployment. So continuous integration is sort of a dependency that continuous deployment has. And so we'll talk about that first. This process is pretty exciting. This is works into what, if anyone's heard of the DevOps, okay? This works into that process. This is part of that workflow, is this continuous integration process where your code is automatically built and tested and integrated, or essentially into, built and tested in an environment that simulates your production environment. It has to be the same type of environment, just one that's not publicly accessible. That would be a good way to do it. And what happened, well, actually in this case it's going to be a test environment. So we'll develop, we'll commit. Does anybody know about Git hooks? Okay, you go into any one of your repos here. I've got one here. I can just see I've got a Git directory, so that has a Git repo. I go into that Git directory, and I take a look here, and I see there is actually a folder called hooks. Okay. Go in here. There's a whole bunch of little sample files. Apply patch, commit message, post update, pre-push, pre-receive. All these things are events that occur within Git. When we push code, an event will get, and it's downloaded that entire chunk of code, it'll then be able to run a script for us automatically. I believe the one I use most often is actually post-receive, and I put it on my remote repo and have it run, build, and then restart my server every push when I make a push. So that's how I deploy to production. That is the sort of commit source control phase of this. It runs the patch, or sorry, it runs the script. The script is just maybe a bash script, which builds my application. That could be as simple as npm install, migrate database. I mean, those could be the things that you have to do when you build your environment or you build your app. That gets done in an environment that replicates our production environment. So chances are you're running the code, and you could even be running the code in production or in a test mode that tries to simulate that, but definitely not development mode. It runs all these automated tests that you've built up, all your unit tests, all your functional tests, feature tests, and then your build goes one of two ways. We'll call it red or green. So when the build goes green, what does that mean? Everything passes, yeah. And when the build goes red, failed. Yeah, there's a failure somewhere. Maybe one of your tests failed. Maybe somewhere in the process it failed. But the idea is that it did not get through that run. And this is where we get reporting. And the reporting is super important because you're going to get an email or a Slack message or something like that. Chances are the person who made that commit that went red, they're going to get an email directly. A bunch of people are going to be CC'd on it. And maybe the whole team will get it. Who knows, right? This is not a bad thing. Being accountable for the commits you make is an important part of software development. Like we have to be accountable for the code we're committing. We're responsible for that. It means we do not commit on a Friday afternoon at 5 o'clock and then go home for the weekend. Just don't do that. And you avoid problems where you get an email while you're on the bus on the way home saying you broke the build. Do you have to go back? Yeah, it's your responsibility, right? So you get used to when you should commit. Usually in the mornings is good. You're there all day. So yeah, so figure that out. But the idea is that we get that early reporting, and everyone on our team knows. And I've been on projects where everything shut down completely. No more commits until that build goes green again. Because we don't want to just compound those problems on top. How do we know if it's the new code that got committed or the old build thing that's still breaking it? We don't. So we just, when some of the teams, we lock down our version control completely. Just you're not allowed to commit anymore. And then when the build went green again, unlock it, now you can commit. Chances are now everyone's committing a whole bunch of changes at the same time. It's going to go red again. But you have to have some control around this. All right. Does that make sense? I hope that your companies have this in place, the places that you go work. I hope that they have this in place. And if they don't, maybe you're the catalyst for change. Okay. If you need help convincing people to do good testing, let me know. I'll come sit with you in a meeting. It's important. Is that important to me? I'll do it for free. All right. So continuous integration now is this big bubble, and it sits over here. So I said it's a dependency. Continuous deployment now means if that build goes green and you have confidence in your tests, we should be able to release that to our end users now, right? This is an ideal situation. If anyone's heard about we've heard about Facebook. What about move fast and break things? Have we heard that? Move fast and break things. That's sort of, they put that on the wall. This is sort of the process that allows them to do that. Because not only when you break something can you, not only do you know early if you break something, but you also, if it does make its way out into production, you have a very easy way to revert that change and take it out. Okay, so if you're monitoring software, because I'm not even talking about monitoring today, but we're going to monitor our applications in production. We're going to find out when there are client-side errors. We're going to find out when there are server-side errors. We're going to keep our eye on that. We get one of those back. Oh, maybe it's that latest change. Bring it. Let's revert it. Code is back to where it was before. This is a reason we make small changes, small confined, encapsulated changes, because then if we just take one back, everything else around it works. If we have to remove all these different changes to get rid of this one feature, that becomes a little bit tougher to deal with, right? So good Git workflow helps us a lot with this. All right, I'm going to say that we're not all super confident in our software. We're pretty confident, but we're going to put in sort of one extra gate. And this, I think, is probably more common. So you automatically, after the build goes green, push that to a staging environment. Staging is an internal-only production environment that can run our code, that we can test it. We can go in there. Manual testers can go in and use it there. Production managers, people that are responsible for the product, they can go and test the software there. They're going to see all their newest changes there really quickly, hopefully. This is actually not a bad process to have. And then once everyone's happy with that and we've been running it in staging for a little while, you press one button, deploy it out to production at that point. Does that make sense? Okay, cool. So I expect if people do CI/CD, that this is probably the more common flow that you'll come up against. You got to be real bold, and you have to have it built absolutely into the culture for this to work. You don't really get it otherwise. Do you know what I mean? Kind of built into the culture. It's not just the developers that believe testing is important. It's the product people. It's the marketing. It's everyone in the company understands the importance of this, so that we don't prioritize features over the confidence that we need to release those features, right? Or we don't prioritize releasing those features over the confidence, I guess, is maybe the way I'd put it. Okay. Lots of tools to help us with this. You can do some research on them if you want. Put some popular ones in there. Put some commercial level ones in there. They're all great. We saw Circle CI, or we didn't see it yet, but I'll go take a look. That's what the React team is using for the React library. Jenkins, Travis, whatever. I mean, lots of options. Some of these are things you would install yourself, and some of them are services you pay for, and some of them are services you pay a lot for. So I'm going to click on this Circle CI passing, and we're going to see sort of the last couple of commits that were made to React here. Okay. And here's a failed build, and here's a failed build, here's a failed build. This one is marked fixed, and this one was just, it was already working. and it ran the tests on the commit, and it's still working, so we get success here instead. But this is how we're going to track this. We're going to be able to see this is going to be matched to every single commit that's made. We're going to get a whole bunch of different the different logs from the different processes that have run here, perhaps. Oh, this is kind of interesting. It's reporting the node version to us, so we know what version of node didn't work there. Maybe if it didn't work. Who knows? Some of this stuff might be absolutely useless to you, and other could be very useful. Kind of have to just spend some time with it. So, all right. CI/CD, how do we feel about that? It's unfortunate. I was doing some interviewing lately, and I tend to ask questions about testing and sort of test process and how the candidate approaches testing, and I got a little disheartened by the fact that a lot of people's response was, I could tell that what they wanted to say was that they did a lot of automated testing, they wrote a lot of automated tests, and they were really proud of their test suite at the previous employment. But none of them could say that because they weren't, and I had to tell them that's not their fault. As a junior developer, that's not your fault if your company doesn't put the time and effort into. That's their fault. That's something that they've decided, and that's what I mean when I say it has to be built into the culture. So, I'm not seeing it as much out there as I'd like to, so don't be surprised. But we want to work towards good testing if we can. I'm going to try and help the next generation, right? And I definitely have meetings with people and companies about this before I get involved with them. Because if I don't think they have a test culture, then should they be paying me to spend time trying to convince them to do that? I mean, maybe, but probably not. Chances are I'm going to have trouble convincing them of all the things that are not just purely adding features to software, which is, in an ideal world, that's what we'd be spending all our money on, right? It's not the reality. So, yeah, I know, sorry to bring you down. Okay, RSpec Ruby testing tool. Let's go back up and talk about stuff that's getting us closer to this ideal. So RSpec is the Ruby testing tool. We've used it already for unit testing. We're going to use it again for integration testing. And it's going to just manage running the tests and reporting back to us information about the tests, okay? So it's a framework that our tests run in. We've also got things like Capybara, which is the integration test framework. This is going to allow us to select input fields on the web page, type information into those input fields, select the next one, type stuff in there. We're not actually typing, it's just going to insert text into it for us. Then it'll click the button. It'll simulate that by clicking the button in the browser. It'll then, we'll move to the next page. It'll allow us to click on, find a button called Add Item and add that to the cart. That's the type of stuff Capybara is letting us do. Okay. Questions before I get set up here? All right. Yeah, of course, please.
Can you talk a little bit about the differences between your test environment and your dev environment?
Okay, yeah, so the differences between the test environment and the dev environment. The dev environment might do, okay, so I guess it depends. One of the things in my different database, for sure. So you're going to use configuration to point to a different database, and that database is going to potentially be wiped clean and reseeded for every test that you run. That's a possibility. That's a big difference between your development environment, whereas you manage that yourself. You kind of tear it down and bring it back up when you want. Everyone might have a different set of data inside of there. But I'd say for testing, everyone's using not necessarily this exact same database instance, but that your tests build the data and then also test that the data is in there. So database is one big thing. What else? Yeah. Oh. No problem, yeah. So Usually it's just like a flag in your software that says what environment you're in. So if I want to run a node app, I guess if I'm running my Jungle application, I could say Rails env equals test, or production, or by default it's development. And so if I say Rails and production, then I do Rails S, it should run the server in production mode for me. And it tells me here that the environment is production mode. And then there's code inside my application that says, is this environment variable? What is it? Is it production? Is it development? Is it test? And I do different things based on that. We're also going to see, I think vim config. Which one is it? Database? No, environment RV? Oops. No, that's the wrong one. Let's see. Okay, I know that it's in our gem file though. So we definitely, there's stuff like this, where it won't even install or use dependencies that are listed under the test only environment. Here's a development, stuff that we'll use just for development, stuff that we might just use for production. So our environment could dictate the packages that are used in the application. A lot of the code might just be well, this would be JavaScript, if process.env.node env equals production, then connect to production DB or something like that. You'll see code like this in your in applications as they start to grow and have different environments that you'd run them in. Yeah.
What's the committing process? Or like, I feel like it's different from when you're developing, like speaking of committing to all the tests that you run.
Yeah, so you commit all the tests to GitHub as well. Usually they're right beside your application. I don't know if there's any in here. Well, yeah, so we're going to be putting tests inside the spec folder. So all those are being committed with our application. Yeah, and then that means any developer or any automated system could run those tests anytime they wanted. So normally what would happen before you make your commit, you run your test locally, and the tests everyone else has written locally. If that passes, then you'd feel comfortable committing and merging back into master. Maybe then, or now you merge master, you run the tests maybe, and then you can push the master branch, and everyone has those changes now. And then when you push master to remote, it's going to now automatically run that through the CI process. Whether or not you deploy directly to your end user or not, it'll still be testing and going through the reporting process for that. Yeah. Okay, sweet. Let's go quickly to here. You need to realize that I've already done this. So assume that I've run this. I've done this. You didn't need to watch me do this, but this is your assignment, one of your assignments today. Capybara and Poltergeist setup. Task 1, install Phantom.js. I've done that. Task 2, install some gems in the test group, so they only get used in test. I've done that. And then set up some of these configuration changes. So follow these instructions, and then you're able to do what I'm doing right now in this application. All right. So we know about generators, right? Rails G. When I Rails G, I see a whole bunch of different generators that I have available to me. Did we know that generators get added when we add new gems sometimes? Is that familiar for people? Okay, so if I install a certain gem, that gem has the ability to insert a generator into my Rails app so that I could use it to generate templates for things if I wanted to. So here's a good example. Money Rails, that doesn't come with Rails, but we have the Money Rails gem. So we have a generator for this. I've never used it. Don't ask me what it does. I'd go to the documentation to find out. You don't need to see that. When RSpec is installed, we get a whole bunch of different generators for RSpec. And when Capybara is installed, we get a feature generator for RSpec. So that's what we're going to use today. Rails G RSpec feature. So it's, oh, actually, let's do this. Git checkout. Just need to get, I guess, RM. There, now I'm back to no more lightning bolt. Okay, let's try that again. RSpec feature. Oh, right, of course, I'm missing one piece. It's telling me the usage needs to include a name. So the name that I'm going to put in is just orders. Because the tests that I'm going to write have to do with maybe that order flow. So I'll give it a name, orders. It's going to be called orderspec.rb. It's going to be in a features directory right here. Right, so spec features orders spec. Now, the app that we're running is just the Jungle app. It's not the same one as you have today because I didn't add all the features, but it does have some of the stuff that we need to test today. So for example, I go over here, I can see a bunch of products. I have this little user thing up here. I can log in or register. I can go to my cart. So I'm going to go log in first at user.com. This is using my development environment still. I log in, I confirm that I'm logged in, and now I could add something to the cart. And now I can see up here that there's something in my cart. So when I click that, I can go here, pay with card, put in good information, something like that. Pay for my red bookshelf. I would never, ever, ever buy that. And then I confirm myself that it says thank you for your order first at user.com, which happens to be the email that I put in the first place. So I would say that this feature works, right? We want to write a script that will do this for us every single time we run it. All right, I'm going to go in here, and we're going to take a quick look at this. So I think yesterday we were using it, or scenario, and it to start our functions off. I mean, these are really just blocks and anyways, right? So for RSpec feature, or for Capybara features, we're going to just use rspec.feature instead of, I think scenario went up here. Is that right? I haven't done a lot of Rails testing. Was it describe? That's describe. It's describe, and then the second level down is it, right? Okay. So we'll use rspec feature instead of describe for these tests today. And then I'm also going to do scenario user orders after logging, or while being logged in, or logging in while being logged in. Something like that. So user orders while being logged in, do, end. And if I ran this without, but with this pending garbage here, it would just error out or warning out to say you have tests pending, you need to write these tests. I'm just going to get rid of that now. I don't even need to show you that. So here's a scenario that the user orders while being logged in, and I need to, what was the first thing that I did for my test here? That was, yeah, that was not the first thing. Or logged in. So I have to be logged out, and there are, if I'm on the root of this document, there are two ways I can get to the login, right? One way is, so I can click this. That's 2 clicks. Okay, so I can do that. Or I could just, and any user is capable of this as well, so I think that either way is fine. The goal is to go to the login page. Excuse me. So here, what I did is I started off by visiting the login page. Let's look at Capybara's documentation. Yeah, I always have to put the name of the language that you're trying to, otherwise I'll just find a bunch of Capybara photos. Which is not a bad thing, because this is pretty darn cool. So here's that Capybara website, and down here we've got API documentation. So we click on that. and it's not as exciting. This is actually a bit of a trash fire over here. This is not the place we should go for our documentation, first off. This is going to give us the entire interface to the application. It's very dry. This is a little bit nicer, though. This is where we're going to see the table of contents with information about using Capybara with different types of test runners. That might be useful to us. Cool. Drivers, so selecting the driver, and then we're noticing there's actually a number of different drivers here. Trust me, they're drivers. Poltergeist is one of them. Capybara WebKit, Selenium, and RackTest, these are drivers. So a driver is just going to be the JavaScript driver, the thing that's used to be able to simulate the browser environment. And it's actually pretty realistic because we'll call it a headless browser, and a headless browser just doesn't have all this stuff, the stuff that we see here, but it still has all the internals of a browser. It still has a DOM, maybe it just doesn't render it, right? So this headless browser is running, has the DOM. We can select things in the DOM, and we can set the values of things in the DOM, just like we do when we're using jQuery. We can do that in our testing as well. And it's this driver that we're using to help us hook that up, our app, to the tests. Okay. So Poltergeist is the one we're using today. Poltergeist is actually a Ruby library. And the reason why we have that is because we need to hook Capybara up to Phantom.js. Phantom.js is that headless browser that I talked about. So Poltergeist is a Ruby wrapper around Phantom.js that allows Capybara easy access to it. We don't really need to know the details about that, but you will find out more a little bit as you set up the configuration. That's what that configuration that I showed you is all about. It's about setting up the JavaScript driver and making sure Poltergeist is the one that you use for that. All right. The DSL. What does DSL stand for when it comes to programming? Domain server. 2 out of 3. Domain-specific language. Yeah. And so the domain we're talking about here is testing. And so the domain-specific language describes the things that we need to do to test. So we'll go to DSL here, and we'll start to see these are some of the things that a user does, right? They navigate. So we need to provide an API to be able to navigate. They click links and buttons, so we need to have an API that allows us to click links and buttons. And this is the domain-specific language. It's just a nice API into writing these tests. Users interact with forms. So what do you do with forms? You fill in and you choose and you check and you do stuff like that, right? So that's the domain-specific language. There's a whole bunch of querying and finding, but the last thing I kind of want to talk about before we start using some of this is scoping. Because scoping is this concept where we focus on a small part of the page, and then within there we do the stuff that we're searching for is only going to be within that scope of the page. So we could have an entire page, but we want to just test just a small piece of it. For example, for us it's going to be within a form, a specific form. We're going to fill in certain values. So the scope is the form, and when I say email, it's going to be email within that form, not just globally anywhere on the page. And this helps us be a bit more specific when writing our tests, let's say, for that. Okay. So now let's go back. Now that we understand a little bit more about the DSL, right? We've got this navigating. So let's say that our application actually starts. I can't go to no page, but it is essentially, it's nothing there. It doesn't make any assumptions for you. So what's the first thing we would do if we wanted to go to start this test? So we want to visit. Which page do we want to visit? That's right, yeah. So we're going to visit localhost 3000/login. The nice thing is that we're running that server. It knows about it. So really we care about the path, and the path is just going to be /login, and we're going to visit that. So visit /login. This is a way we can do that in our test, right? Now, how do I make sure that it's gotten to that page? It's a headless browser. You might not know the answer. It's okay. You probably don't. We want to be able to save, I think it's This is one of the ways we're going to debug our tests. We're going to use this, I think, save screenshot. I can always just go over to the Capybara docs, save. Yep, there's a save screenshot, and I give it the name of the screenshot. So I'm going to run this now and see what happens. RSpec. So just so you know, I'm running Vim, and I can go into command mode, hit exclamation mark, and then type in the command that I want to run. It's the same as if I quit, and then I just ran RSpec here. I'm just doing this, but then I don't have to start Vim over back and forth. So let's just say, well, first one we'll just run it here on the command line. Oh, and it says cannot save. Oh, okay. This is interesting. Save screenshot is not working, and it says it's a Capybara error, not supported by the driver. So I actually know what's going on here. Oops, and it's because I missed an important part, that when we are using the JavaScript driver, we have to enable it for this set of features. So keep this in mind. The tests that use the Capybara and Poltergeist and Phantom.js, they need JS to true. So now I'm going to run RSpec again, and then we'll take a quick break after this, okay? There we go. It has passed the test. That's okay. I didn't expect it not to. But what we want to look at here is in the Jungle folder. I have to put this down, two-handed. So in my Jungle folder, scroll down to the TMP directory. And inside TMP, Capybara. And I'll just get rid of these old ones. I'll run it again. This is my Capybara directory, and there's an order PNG just got created, and I'm on the login page. So I'll continue to use this to make sure that it's showing the information in the page that I want to see. Any questions about that before we take a break? Okay. Take 5-10 minutes, and then we'll come back and write up this test, yeah? Oh, is it like broken? I'm like frozen here. Yeah, something's broken. Oh well.